이번 동영상은 폰트리아진's 맥시멈 프린시플에 대한 강좌를 시작하도록 하겠습니다. Classical variation method and the maximum principle. The optimal control problems are concerned with the dynamics that describe the following ODE, ordinary differential equations, x dot equal to fx, where x는 m vector is the state variable vector and u는 m vector인데 is input variable vector. Our problem is to find ut, t는 t1, t2 that transfers the state variable from a given initial state xt1 to a given final state xt2 under the condition that the whole trajectory minimizes the following cost function. 이 cost function이에요. In most engineering problems, ut is subject to practical constraints. In other words, u must be entry of a given subset u, large u, of an n-dimensional Euclidean space, namely u subset large u m vector space. Basically, this problem is a variation problem, and Pontryagin maximum principle is an extension of the classical variation method. The difference is that Pontryagin maximum principle can deal with closed sets of u. Needless to say, problems with a closed sets of u are extremely significant from the engineering point of view. The joint torque factor tau m vector over lava manifold usually has following constraints. Many important problems would not have solutions if they had to be solved using the classical variation method with the following often set constraints. In Pontryagin maximum principle, the input variable satisfying all the imposed conditions is called an admissible control. Definition 1. Admissible control. An input variable u, m vector, is called an admissible control if it satisfies following four conditions. U is an entry of a given subset large u in m vector. ut is defined over like this. ut is piecewise continuous and defined at the discontinuous point td by the left limit. That is utd left limit. ut is continuous at t1, t2. Mathematical conditions on fxu in x dot fxu and on f0xu, 이거는 스칼라입니다. q는 f0xu. x는 m vector, u는 m vector. Are summarized as follows. fxu is defined over arbitrary x m vector or u large u set. fxu is continuous with respect to x and u. fxu is continuous difference with respect to x and u. f0xu and round f0 round x are defined over the arbitrary x in r and u. f0xu and round f0 round x are continuous with respect to x and u. The maximum principle x dot fc component-wise x dot fi xu, the x는 m vector고. Now using f0 xu in equation 2. We define additional state variable x dot f0 xu 이거를 하나 집어넣어요. x0 t1 0 여기서 나온 거예요. Combine equations 6 and 7 we obtain augmented dynamics x dot 0 f0 xu x0는 x0 포함해서 x1 xn이고 근데 n 플러스 1 벡터고 f0 f0 f1 fn인데 n 플러스 1이고 we introduce a vector psi 0 in n plus 1 vector and that has the same dimension as the x0 and correlated adjoint vector. Hermitian. Matrix A Hermitian, aij Hermitian, aij transpose, consecutive transpose, aji star. 요거는 transpose. A Hermitian, Aij, A-H는 skew Hermitian. Hermitian of the joint or the joint는 여기 in the product는 AX, Y, Y 하고 같은 거다. The Hamiltonian is defined using the joint vector as follows. F psi 0 x 0 u는 psi 0 transpose F0 x u. Using this Hamiltonian, the behavior of x0 t and psi 0 t are determined by the following Hamiltonian form. x dot 0는 라운드 h0 h0의 트랜스포즈 이 컬럼 벡터는 요거 하면 로 벡터거든요. 요런 컬럼 벡터. psi 0 벡터는 마이너스 라운드 h 라운드 s 요 로 벡터를 트랜스포즈해서 컬럼 벡터를 만듭니다. H0는 F0 XU는 psi 0 F0. psi 0는 이 자체를 psi 0에 하면은 요놈이 나오죠. 근데 equation 10 is equivalent to equation 8. 그 요놈이 누구한가 하면 equation 8하고 같은 거지. 요놈하고 같은 거지. Therefore, equations 10 and 11 determine only the behavior of joint vector psi 0 where H0 psi 0 transpose F0 결정해 준다 이거지. CLM1은 다음 동영상에 올리겠습니다. 감사합니다.